Hello, this is the third experiment of System Software and Compiler Lab. In this, we have to work on uh, in a macro process, in a function of macro process. First, we have to write a program to simulate the functions of a macro processor. So, what a macro processor is? A macro processor is uh, just a simple program uh, which will convert any program which the user gives into a shorthand version of the program itself, and this process is entirely known as module programming. So the macro processor replaces with each macro invocation which corresponding sequence of statements which is defined as expanding. So let's move on to the program. So this is the program. Initially, initially, first we have used getLine function to get input from the user, and processing line in which we are processing each and every function with a macro, and define function is a part is a function where we have uh, created definitions for a macro, and expand is where we are expanding the program, right? And file input and output. So input is in input part um, we have to first take input from a input.txt file, and we have to print output into output.txt file. So initially, first we have set all the required variables and all, and we have created structures here, and definition tab here, and arguments tab here. So moving on to the main part. First, we take input. First, we take input from the for this program to run from an external file. Using the read function of the command, like input.txt/r. Okay, reading this part, and output we are writing it into the external file which is output.txt with the function called write w, and we are running a readline function here, and we are in getLine function. We are using while loop to initiate the extraction of each and every function from the input.txt file. So moving on to the later part, we are giving the message as that expand the file has been expanded if the processing is done entirely correct. That means if we reach the function if we reach the statement end, in input file we will be giving end towards the end of the function. Whenever it reads end, the function will stop, and we will get the required output in the external file. So in this part, basically we are storing each and every word which we are getting from the input file, and storing buffer. Buffer is basically we have defined so that the moment when the program is running, we are taking the function and converting it into the macro. In that process, we are storing that word into the buffer variable. So if the function is if the input file is expanding, then we are performing this current operation by replacing each and every function with a macro in into the output file. And if not, then we are getting out, okay, out of the input function. That means the program is not eligible for macro conversion. Okay. Moving on to the next part. This is process line. Here we are processing each and every word, each and every word, that each and every variable functions from the from the processor into the macro. And we in this part define function, we are defining the macros. How that means for which function we are going to define what macros. Okay. And moving on to the last part, here the expanding part, the final writing of the writing of the macros into the external file, which is output.txt, is done in this part. Okay, and until then, if the expanding becomes, and after each cycle, when after each cycle we are setting expanding value as 0, so so that we will get the desired output, and the function will, and this program will not go to the infinite loop. Okay, let's move on to the input part, input file. So this is the input. This is the input program. Initially, we are starting to copy. We are starting from the address, which is 1000, and we are writing this address into the processor, and we are reading macro from the variables PQ, from the PQ and R. We are clearing the assembler, A, which is the assembler. S and X. S and X are the different registers present in the processor, and we are doing the other required operation here. And moving on to this, we are comparing if the value stored in the assembler is equal to the value stored in the R register. Okay, and moving on to the next part, this is the main part. This is the main part. This is just a program, and this is the main part. When the program is running, the program will be reading from here, and using this function read buffer f1, buff1 l1, we are going to read this particular part, and write it into the output.txt file. And towards the end, we are storing, we are using stf function to store that entire store the output part into an external file. And towards to finish up the program, we are giving the end function. Like I mentioned earlier, there is a function return end. If this end matches with that end, then the program gets over, and we get the desired output in the external file. Let's move on to the working of the program. See, in which uh, okay, so the program has been successfully compiled, and let's move on to the output, if we are getting the output or not. Okay, so it gives the C program of macro opcode assembler. So this shows that expanded output file has been successfully created. That means there are no errors into the program. Um, let's go on to the output section. Yeah. So, this is the output file which we got. So first, initially, like usual, it started to store. It started by storing 1000 as an address of the microprocessor, and then it was reading and writing. See, like I told earlier, this was reading the first string reading operation. First reading operation, writing operation is done in this part, and the second in the here in this part, and the third is this part. Like I will show you here in this part. See, this is the function where we are reading the program three times. See, read buffer f1 and read buffer f2 and read buffer f3 three times. So the program has been uh, read three times, and the equivalent macros has been produced in subsequent times whenever the program is run. So we got the output as we got the desired output with respect to the macro processor, sorry. And so this would be the last of it. Thank you.